In computational biology, every dataset is a dish someone else cooked. You have the finished product and a list of ingredients, but you don't know the recipe. Regression is how you reverse engineer it. Welcome to the recipe lab. Start simple. 1 ingredient, sugar. 1 outcome, sweetness. Add the tasting scores on a plot and draw the straightest possible line through them. That line minimizes the total distance from each point to the prediction. This is ordinary least squares, the foundation of every regression method. In biology, this is predicting a gene's expression level from a single transcription factor's binding strength. 1 predictor, 1 outcome, 1 straight line. Now the pantry has 50 ingredients, and many are nearly identical: oregano, thyme, basil, all herbs. The old chef panics. It cranks 1 herb to maximum and another to minimum, producing an absurd recipe. Enter the rid chef. A calm hand presses every slider on the mixing board toward the center. No ingredient gets eliminated, but none goes extreme. This is regularization, a penalty on the total size of all coefficients. In genomics, this handles thousands of correlated gene expressions. Rich shrinks everything modestly. It never drops anything entirely. Same 50 bottles, but a different chef walks in with scissors. She doesn't just shrink, she cuts. Most ingredients get removed from the recipe entirely. Their coefficients go to exactly 0. Only the handful that truly matter survive on the counter. This is LASSO regularization. The penalty is sharp, like a blade. It performs variable selection, finding 5 meaningful biomarkers out of 20,000 genes. When you need a short list of what matters, LASSO is the tool. What if some ingredients should be eliminated and others just tamed? Elastic net puts both chefs at the same mixing board with a dial between them. Turn it toward LASSO for aggressive selection. Turn it toward ridge to keep correlated ingredients together. The alpha parameter controls the blend. When you don't know which strategy fits your data, elastic net is the safe default. Before the head chef touches anything, a prep cook consolidates the pantry. 50 herb bottles are combined into 3 master blends: Mediterranean, Asian, Latin. Each blend is a weighted combination of the originals. Now the chef works with 3 jars instead of 50. This is partial least squares, reducing many correlated predictors into a few uncorrelated components. When you have more ingredients than dishes to taste, more predictors than samples peels makes the problem manageable. 5 strategies for cracking the basic recipe. ULS for simple cases. Ridge when everything is correlated. LASSO when you need to find the needle in the haystack. Elastic net to blend both. And pills when the pantry overwhelms the palate. Next time, what happens when the outcome isn't a continuous score?